During week 2, we learned about ways we can measure energy sustainability. Specifically, we explored these concepts. What is a sustainability indicator? What are some common sustainable indicators related to energy? How do we assess sustainability indicators? What is community sustainability? What are some advantages and disadvantages of sustainability indicators and the community sustainability approach? What is the IPCC and what is its role in climate change assessment? How is climate change connected to energy production and use, and why should we care? What does clean energy mean? What are the challenges of achieving a sustainable energy future in the face of rapidly growing nations? First, what is a sustainability indicator? Although neither of these required readings explicitly defines the term sustainability indicator, they both provide enough context clues for us to be able to derive a definition. The authors of the article, A Guide to Community Sustainability Indicators, state that sustainability indicators must be simple and directionally clear. Under simplicity, there should be a limited number. The authors suggest 12 to 15 indicators as an appropriate amount. And the method of calculating the indicators should be transparent, so others can reproduce the same calculations. Under directionally clear, the authors say to indicate items and trends obviously relevant in terms of importance for sustainability, and to be sensitive in order to signal progress or the absence of progress. This directionally clear requirement is, ironically, not very clear, however. It is very subjective depending on which decision maker you are talking about. One set of trends may be important to one decision maker, but not important at all to another. And one decision maker may define progress completely differently than another decision maker. The authors go on to define a set of systemic questions that must be answered when defining sustainability indicators. Which interests have to be involved in developing indicators? How broad a participation can be managed? Which indicators are good and which are bad ones? How should a set of sustainability indicators be used in decision making? Answering these questions will help limit the subjectivity of the directionally clear requirement. The authors identify 4 dimensions of sustainability in their prism of sustainability. 1. The institutional imperative, which has to do with human interactions and rules, including organizations, mechanisms, and orientations. 2. The social imperative, which has to do with the aggregate of human capabilities. 3. The economic imperative, which has to do with competition. And 4. The environmental imperative, which has to do with the total amount of resources extracted from the environment. The authors also explain that the interlinkages are just as important, if not more so, than the 4 dimensions. These linkages include 1. Equity and distribution of access to limited resources, the social environmental linkage, meaning that limited resources should be distributed equitably to all. 2. Democracy, the institutional social linkage. This is a basic condition necessary to create a society of more tolerance and solidarity. 3. Burden sharing, the social economic linkage. This is the basis of the welfare state, that the haves help the have-nots to meet their basic needs. 4. Care, the institutional environmental linkage. This encompasses dedication and action. The authors note that the limits of society's carrying capacity will probably be as essential as those of nature's carrying capacity. 5. Total material requirement, or TMR, or eco-efficiency, the environment economic linkage, which is a physical measure characterizing the resource use for the totality of economic activities. And 6. Justice, the institutional economic linkage. The authors also state that a sustainability indicator should not be derived from the aggregation of data, because this undermines the requirement of data transparency. Also, we should select indicators that characterize the most relevant trends. This was part of the directionally clear requirement, and as mentioned before, this depends on the values and preferences of the decision maker. Therefore, the development of sustainability indicators should be a participatory process, and the indicators themselves should be prioritized using the prism of sustainability in order to support a broad and balanced coverage of environmental, social, economic, and institutional issues. I would also add technical issues to this list. The authors outline a 6-step dynamic process for developing sustainability indicators. 1. Prepare the process. This must be a political process on some level in order to make it cause lasting change, i.e., there must be some political action attached to the outcome. Number 2, form a working group. Diversity is the key here. The more diverse the group, the more likely there will not be opposition when the changes are implemented. 3, define the light build, the perspective of desirable and possible. Integrate as many conflicting options as possible. Number 4, choose indicators and data. Don't copy from other communities, but develop on a local level and publish the draft for discussion. Number 5, discuss targets and measures. These must be realistic, measurable, and achievable, and they must represent commitment by all decision makers to really take action. And 6, follow up. Host open forums to reflect on the process and how the community feels about the changes. Be sure to change indicators with changing concerns over time. Again, this should be a dynamic process that adapts with time and changes to reflect the community. The authors provide an example of goals and indicators for the city of Iserlohn in Europe. Here you can see there is a mix of indicators that represent different dimensions and linkages. And the indicators are measurable. For example, number of citizens' hearings, amount of money paid for testing ecological technology, number of people finding a job because of their training course, etc. Returning to the original question, as mentioned before, the authors don't explicitly provide a definition for sustainability indicators, but after reading the article, one can be deduced. A sustainability indicator is a piece of data that provides information on how well a certain dimension or interlinkage in the sustainability prism is performing. It should be simple and easy to understand for the average citizen. The method of calculating the indicator should be transparent so others can replicate the calculation. The indicator should represent decision-maker values and the light build, the desirable and possible. It should also be developed through a local participatory process. Incidentally, this article is also explaining community sustainability. It defines this term as a composite and ambitious policy target comprised of environmental, economic, social, and institutional criteria of equal importance. And I would of course add technical criteria to this list. It is based on sustainability indicators that have been agreed upon and defined through a participatory process with a diverse group of decision makers at a local level. But how do we define local here? When we include greenhouse gas emissions as an indicator, the local community becomes the global community, and it becomes very difficult to manage the values and opinions of a community as large and diverse as the world. So, while this article provides some interesting and well-designed ideas of how to design sustainability indicators in an optimum setting, it may be a challenge to implement in the case of energy issues, which are often local, regional, and global all at the same time. The article, Assessment of Sustainability Indicators for Renewable Energy Technologies, provides more information to help define the concept of a sustainability indicator, and also identifies common sustainability indicators for energy. It also explains how to assess these indicators. The article reinforces the requirement that a sustainability indicator must be measurable by defining it as a quantification of impact. The authors also note that it is based on environmental and societal impacts, greenhouse gas emissions, resource depletion, availability of renewable energy sources, and the value they add to the economy. Although they don't say so explicitly, they are including the 4 dimensions of sustainability outlined in week 1 of the course: environmental, social, technical, by including availability, and economic. The article examines the following sustainability indicators related to energy. For technical, they look at availability and limitations, such as for photovoltaics, the fact that it's not available during clouds and nighttime. For wind, that it's intermittent and can't operate when winds are too high. And for geothermal, that is geographically limited. Also, efficiency of energy transformation falls under the technical criteria. And they define this as a percentage, although the calculation is undefined. They also look at economic indicators, price of electricity generation in dollars per kilowatt hour, environmental indicators, greenhouse gas emissions in grams of CO2 equivalent per kilowatt hour, and land use requirements in kilometers squared per terawatt hour, and water consumption in kilograms per kilowatt hour. Social indicators include the opportunity for electricity supply that otherwise might not exist, for example in rural and isolated areas, independence from fossil fuel imports and price fluctuations, toxins, visual impacts, bird strikes, noise, displacement of people and animals, agricultural impacts, seismic activity, odor, pollution related to health damages for the society. The authors also discuss different methods for assessing sustainability indicators, such as input-output analysis, mass and energy balances, emergy, which is embodied energy, life cycle analysis, LCA. They spend most of their time discussing this method because it can combine the other methods and it is the most comprehensive of the methods listed. LCA attempts to measure the full footprint or entire energy chain life cycle, including mining, processing, direct and indirect emissions, waste disposal, and/or recycling. Keep in mind, though, that LCA does have its limitations, too, and many LCAs are not as comprehensive as this. Also, sometimes LCA is not the appropriate method, especially in cases where regional or local impacts are more important than global impacts. We discuss these issues more in depth in ECO 405, Sustainable Energy Economics and Policy. The authors present comparative data for several electricity generating technologies across several sustainability indicators. Please do not treat these data as absolute, since the authors just compiled a range of data from the literature. They did not do any analysis to account for different methodologies, geographic differences, or differences in time periods. This type of analysis is essential when comparing energy options. So the graphs and tables in this paper should be used as an example for how data like this could be presented when proper analysis has been done, rather than as an absolute source of information for any one energy option or sustainability indicator. We will look at more accurate sources for these indicators and energy options as we delve into Units 2 and 3 later. In particular, the authors don't even define the term efficiency when they present this table. Since there are many ways to define efficiency, the numbers presented are essentially useless. However, it is useful to show an example of a table comparing efficiency values for different energy options, so you are aware that this is an important technical sustainability indicator that should be well defined and presented in analysis. Also, the social indicators they present are qualitative. There are actually many studies that attempt to quantify these, and we will look at some of these since quantification is a key requirement for useful sustainability indicators. Due to these data limitations and to the fact that the authors do not explain the procedure or calculation they use to obtain these rankings, you should take these rankings with a grain of salt. However, ranking energy options based on sustainability indicators is a useful tool, and there are other studies that have done a more transparent job of this. We will look at some of these studies later in the course. For now, the main value of this article was to provide more information on what a sustainability indicator is, what some common ones related to energy are, and how to assess them. The third journal article, Energy, Economics, and Environmental Impacts of Renewable Energy Systems, along with the 4 switch videos, provide more information about specific sustainability indicators that are important for energy decision making. Some additional sustainability indicators from these sources include price of externalities like pollution that we don't currently pay for, ability to transport resources from one location to another, reliability, the effect of political and weather disturbances on accessibility, solid waste like coal ash, nuclear waste, for example, acid rain from nitrogen and sulfur oxides, the scale of infrastructure, timing to pay off debt, construction timing and logistics, energy payback time, cost of electricity generation. This can often be different than price. The journal article provides equations for calculating energy payback time, greenhouse gas emissions, and cost of electricity generation. The other materials discuss climate change in more detail and the role of the IPCC in climate change assessment. Many argue that this is the most pressing sustainability issue of our time, for as the IPCC report shows, The consequences associated with climate change are expected to be catastrophic in some cases and have environmental, social, and economic impacts. These impacts may include severe droughts, floods, storms that completely destroy ecosystems, cities, and coastal areas, along with increases in temperature leading to human health problems such as heat stroke and death. The likelihood and severity of these impacts are directly related to the concentration of greenhouse gases in the atmosphere, which is measured in parts per million, ppm. Scientists disagree on what specific threshold cannot be crossed to avoid the most severe impacts. Some say 350 ppm, which we have already passed. Some say as high as 450 ppm. However, we are already up to 400 ppm, and scientific evidence is mounting that we are already experiencing climate change impacts, such as rising sea levels, melting ice caps, and increased severity and frequency of storms. In general, scientific evidence is becoming more and more definitive on the fact that climate change is happening now, and it is being affected by human actions, mainly the burning of fossil fuels for energy, to the point that some say that climate change evidence has the highest level of consensus among scientists of any other issue in the history of science. There are ethical and equity issues tied in with climate change, as discussed in this film. The countries that have historically produced the most greenhouse gas emissions that contribute to climate change are not necessarily the ones that will be hit hardest by climate change effects. Also, developing nations are increasing their energy use at an incredibly fast pace, so although developed nations have led the trend in most greenhouse gas emissions in the past, developing nations are catching up and surpassing developed nations. This leads to a social issue in which some argue that developing nations must curb their emissions by slowing development, and others argue that developing nations should have the freedom to achieve the same standard of living as developed nations, regardless of the greenhouse gas emissions released, because it is the responsibility of the original polluters, i.e. the developed nations, to curb emissions. All of this material should help you appreciate the many challenges related to assessing sustainable energy. For example, clean energy can mean many different things depending on which sustainability indicators you choose and how you measure them. Achieving sustainability is complicated by local, regional, and global issues, such as local acceptance of energy options based on social and environmental indicators, global responses to climate change and the inequity of development and standard of living in different nations around the world, lack of understanding of scientific evidence related to climate change, and I know you have identified many other challenges through your group discussions as well. In week 3, we will be taking a step back and measuring and making sure we are all on the same page about some fundamental concepts related to what energy is and how we use it. In Units 2 and 3, we will be evaluating individual energy options across several of the sustainability indicators you explored in week 2.